Alright guys, here is video number 2. This is starting on page 527 and we are looking at the graph of now the tangent function. Alright, so just like with the other two, the sine and the cosine, I want to start with a table. I think this is essential in helping you remember what the graph's going to look like. If you can remember the table and you can remember the values from the unit circle, it's really going to help you out. If you look down here, we're not going to be asked to find as many things for the tangent function, and we'll talk about why that is here in a second. Okay, so thinking back to our picture, right, our unit circle picture. Again, the input is the angle, the output is the ratio of sides. So if I go right here to angle 0, right, the xy value here is 0, 1. Now, remember how there's a few ways we were able to deal with tangent. Tangent was the y side over the x side. It was the opposite over the adjacent, which in the case of these triangles was the y over the x. It was also the sine over the cosine. So any way you want to think about it, you can find the tangent. So when the angle is 0, the tangent ratio is y over x. So this is, and I'm sorry, I mislabeled this point. Hold on. That's 1, 0. So when the angle is 0, the y over the x is 0 over 1, 0 over 1, which is just 0. So 0 over 1 is fine, that's legal, you can type that in your calculator. So here is our first value. Now, if I go to something like pi over 6, okay, pi over 6, which is 30 degrees, using my special right triangle. If you remember this point here, this was root 3 over 2, comma 1/2, right? So if I do that y over x, 1/2 divided by root 3, when I multiply by the reciprocal, I'm going to get 1 over root 3, and then I need to rationalize that. So that's root 3 divided by 3, okay? If I do pi over 4, that's the 45 degree. If I do pi over 4, right about there, pi over 4 is nice because I get root 2 over 2 divided by root 2 over 2, which is just 1. So far I have two nice values, one at 0 and one at pi over 4. Okay. If I go to pi over 3, which is 60 degrees, my tangent ratio is root 3. And if I go up to pi over 2, right, pi over 2 straight up and down, the xy value up there is 0, 1. So straight up and down, the xy is 0, 1. So if I do that y over x, I get 1 over 0. Now be careful. 1 over 0 is illegal. You're not allowed to divide by 0. So this is an undefined value. Now, just like we saw with our rational functions, when we have 0 in the bottom, that's undefined. That's going to give us a vertical asymptote. Remember, an asymptote is a line that a graph approaches but does not intersect. Okay, so we have asymptotes. Okay, we're going to have a few of them. Now, let's see what we have going on so far. If I plot these points, I have 0, 0. Okay, pi over 6 is a little bit more than 0.5, and root 3 divided by 3 is a little bit 0.57, 0.58. So for the pi over 6 point, it's a little bit, it's like 0.5 and a little bit over 0.5, somewhere right about there. Okay? Pi over 4 as a decimal is 0.78, and that is, let me move that a little bit, 0.5, 0.5, right about there. 0.8, we're at 1, right about there. Okay? And the next point is pi over 3 is 1, a little bit over 1, and there we're at root 3. The square root of 3 is 1.7. So a little bit over 1, right about there. We're up at 1.7-ish there, okay? Now look, the next value we have is at pi over 2. But in between pi over 3 and pi over 2, there are a million angles, right? There's a ton of them. But what's going to happen here is that your value here, see how we're going in this, we're going in like an upward trend here, right? The tangent value is going to keep getting bigger and bigger and bigger. If you want to try it on your calculator, you can see. If you play, it'd be easier to see in degrees. But if you start plugging in like the tangent of, 88 degrees, you're going to get a pretty big number. If you type in the tangent of 89 degrees, you're going to get a bigger number. If you type in the tangent of 89.999, you're going to get a bigger number. And it keeps going, right? 89.999999 is going to be a bigger number. So what happens with this tangent, as we get close to pi over 2, the tangent ratio just gets larger and larger and larger, okay? Pi over 2 is about 1.6-ish, okay? So right about here is where we have our vertical asymptote, and we approach it just like we did with our rational functions. So this piece of the graph is looking something like this, going up there like that, all right? Now, the reason it gets bigger, the reason these tangent ratio is getting larger when you go from 88 to 89, so if you think about our triangle here, right? When this triangle gets to be a right angle like this, right? So maybe that's 88 degrees or so. The y side here is getting longer, right? This is the y side is getting bigger. The x side here is getting smaller. So whenever you have a big number, a big y, divided by a small x, you're going to get a big number, right? You can mess around with that on your calculator. But a big number divided by a small number, again, the big y here, the small x here, as my angle gets closer to 90, is resulting in this graph shooting up forever. But that's a good conceptual problem. You could check them on your calculator as well. So that's where the tangent graph, that's what it's looking at. Now, here's where tangent gets a little unique, different from sine and cosine. This is another periodic function. So just like sine and cosine, this goes left and right forever. But now, instead of continuing over here, we already hit one asymptote. So there's something going on over here to the left of the graph. So to make this a nice, good-looking graph with one period, we don't want to go any further to the right. We actually want to start going over here to the left. Okay? Now think about this. Negative angles are just down here in quadrant 4, right? So the xy values are the same numbers as the top, but for example, at 7 pi over 4, which is also negative pi over 4, the xy value is root 2 over 2, comma, negative root 2 over 2. So the only thing that happens when we go to these negative angles is that the tangent value becomes negative, right? A negative y divided by a positive x is going to give me a negative tangent value. So for example, if I plug in negative pi over 6, okay, that's in quadrant 4. Remember, negative angle just goes in a clockwise direction. So right there is negative pi over 6. My 30, 60, 90 triangle would have the same values. The only difference is my tangent ratio is going to be negative root 3 over 3. If I do negative pi over 4, it's going to be negative root 2 over 2 divided by positive root 2 over 2, so it's negative 1. If I do negative pi over 3, it's going to be negative root 3. And if I do negative pi over 2, now negative pi over 2 is straight down, right? That's going to be the x over y there is negative 1 divided by 0. The y is negative 1, but that's still undefined. So at negative pi over 2, which is negative 1.57-ish, all right, I get another asymptote right about there. All right, and these values kind of mirror each other, right? They get flipped down here. The only one I'm going to graph is negative pi over 4, negative 1. Okay, we said pi over 4 is approximately 0.8. So negative 0.8, negative 1 is right there. And I'm going to get the same shape just going down now. And there's your tangent function. It kind of looks like our y equals x cubed functions, right? It has that snake-like shape that goes down and then up. And these are different than the sine and cosine graphs because they do go up and down forever. We'll talk about that in a second. I'm not going to ask you for the range, but that's what is happening. Now, here's a few cool things to notice. Number one, our period. Now remember, the key values we're going to use to graph this are going to be 0, 0. We're going to use pi over 4, 1. We're going to use pi over 2, undefined, that's the asymptote. We're going to use negative pi over 4, negative 1, and then another asymptote. So we still need 5 values, okay? Now, the difference with this, though, is look how far it is between these asymptotes. If you go from positive pi over 4 to negative pi over 4, right? That's a distance of pi radians. So my period for tangent is pi. That's the number one difference between tangent, well, that's another difference between tangent and the cosine and sine graphs, is that we have a different period, okay? Now, just like before, I'm only going to ask you to graph one period, but if you kept going here, you'd have another asymptote. You'd have to go, you'd have to go to pi over 2, so about 1.7-ish. So what would happen here is if you kept going from this asymptote here, right, this first one, the next asymptote is going to be pi units away, right? Pi units away. If you went approximately pi units away, which is, 3.14, that would take us out to 1, 2, 3, about here. And if you plugged in points, what you'd see is you'd see another curve, the exact same curve. Remember, this is a periodic function, so you'd have an x-intercept about there, and you'd go up like this, okay? So, and you'd have some going back here to the negatives, you'd have it like this, you'd have it like this, right? So the tangent function's periodic, the curves keep going, the asymptotes keep repeating, right? They're always going to be pi radians apart, right? Because it's a periodic function. Okay, so let's stop there and we'll talk about the next part. So the period's pi. The midline is y equals 0. Again, the midline is right there, the x-axis here today. Notice I'm not asking for the amplitude. There is no amplitude here, technically, because the tangent graph does not have a maximum or minimum. It goes up and down forever. I'm not going to ask for domain and range. That will be a skill you'll learn in pre-calc, but I am going to ask for some asymptotes and zeros. Now, here's what you got to remember with the asymptotes. Remember that there's, number one, there's infinite numbers of them, right? There's asymptotes here, and this curve keeps repeating. That's very sloppy, but you know what I mean? The same shape keeps happening over and over again, right? This is a periodic function. So once you have a few asymptotes, you should be able to list all of them, okay? Now, because there's infinite of them, I'm not going to say just, there's just two. This is the two I graphed. I'm going to say this, ... meaning there's a bunch before. And I'm going to name the first one I know. Here I know that there's negative pi over 2, right? That was my first one. The next one was positive pi over 2, right? And you should be able to list some more just from this pattern. Remember, the period is pi, meaning that the distance between each asymptote, whether you go to the left on the xy graph or you go to the right, is always going to be pi radians, right? So let's say I wanted to add another asymptote to the left. If I'm at negative pi over 2, I want to go left pi units, I'd have to subtract another pi. Now, of course, these need common denominators, so I make this 2 pi over 2, and I get negative 3 pi over 2. That would be another asymptote, okay? Now, let's say I wanted to go one to the right. I know I have an asymptote at pi over 2, right? I'm going to kind of label this asymptote there that I drew in. So if I'm at pi over 2, the next asymptote is going to be one period away because it's a periodic function. That's 2 over 2. The next asymptote is going to be at 3 pi over 2. So 3 pi over 2. And the next asymptote is going to be pi units away, pi units away, pi units away. So don't put a period there. This is not the end of the asymptotes. This is just a few of them, all right? So I'm still going to label this with an x equals. Let me move this over a little bit. All right, because these are vertical lines, x equals ... and then list a few asymptotes. Now I'll ask for a few of them. You should be able to use the pattern to show me as many as I want to see. Okay? Now, the zeros, another name for x-intercepts, work the same way, right? You know that 1, 0 is at 0, 0, right? Right here in the middle, okay? So we're going to label, we don't have to label them as points. We can just list the x zeros, kind of like when we're solving, right? You would solve and get x equals 0 as your as your solution, and then you make it into a point. Well, we already have the x equals for the asymptotes, so I don't want to get confused. So one of the zeros is 0. Now, there's ones before that, right? There's an x-intercept over here, and then over here, and then there's x-intercepts over here, and then over here. And one thing you got to remember, because it's a periodic function, those x-intercepts are always going to be pi units apart. So if I wanted to go left more, the next previous x-intercept left of 0 would have been at negative pi, right there. If I go to the right, and again, that could keep going. If I go to the right, after pi, the next x-intercept is going to be at, after 0, the next x-intercept would be at pi, and then 2 pi, and then 3 pi, right? We're not graphing all of these, but you should be able to use the pattern you know about a periodic function to label a few zeros and a few asymptotes. Okay, so that's how it's going to work, okay? We're just going to graph one period, though. So but for the asymptotes and the zeros, you should be able to keep the pattern going. We're going to use these 5 values, right? The 0, 0, pi over 4, 1, pi over 2 undefined, and then negative pi over 2 undefined, and negative pi over 4, negative 1, okay? Again, one period is fine. On the first 2 graphs on the homework, I do more than one period, but as long as you can graph one period, you're doing fine. Remember, an asymptote is something that approaches. Now, I want to show you this as well. Now, there is, like I said, I've showed this a few times for sine, for tangent, for cosine. Now let's change it to tangent, okay? Now, tangent, there is no amplitude, but the a value is still important. We'll talk about that in a minute. The a is still a vertical stretch, shrink, or a flip, okay? So it still does all that stuff. Stretch, shrink, and flip, okay? The period now, like we saw in the last one, is not 2 pi, it's pi. So if we want to stretch that or shrink that, we're still going to divide that by b. So that doesn't change. The divided by b part. The only thing that changes is now pi is your starting period. Okay, let's try one. So check it out. Pretty basic graph. I got 3 over 2. Again, that's not my amplitude, but that is going to affect something in the graph. My period, because there's no b value, is just pi. Y equals 0 is my midline. All right, let's start sketching this, and then we'll talk about the asymptotes and the zeros. So I know my first point is going to be right here at 0, 0, and I know I'm going to travel my asymptotes. One is going to be here at pi over 2. The other one's going to be here at negative pi over 2. Now, remember, it's got to be one period between your asymptotes here, right? That's one period. Negative pi over 2 to positive pi over 2 is pi, which is right there. So you got to watch out for that little trick. That's going to be a little harder when we start changing our periods. Now from there, pi over 4, right, is my next key point here. Pi over 4. And then just a little bit. All right. And at pi over 4, on the parent function, it's up at 1. Let me label this too. And then negative pi over 4 is over here. All right, so there are my 5 key values. I get 0, 0, right? Or I get x is negative pi over 2 is an asymptote, then negative pi over 4, then 0, then pi over 4, then pi over 2. Now, on my parent function, at negative pi over 4, I was down here at negative 1, right? But look at what I have here. 3/2 is a vertical stretch of 1.5. So instead of having this value here and here at 1, these are going to be stretched vertically to 1.5. So although these don't have amplitudes, right, the a value out front still stretches. It kind of it stretches these points here up and down, or it could shrink them closer to the x-axis as well. But once you have that, you don't need 4 points, right? You don't need more than 3. You could always label more, but this is the bare minimum. And what you're going to see is your sketched graph looking something like this. Remember, it has that cubic shape function. And this one, we'd have to graph more of it to see more of the curve, right? But there it is. It's not a straight line. All these graphs, if you zoom out far enough, have this kind of shape to them, right? But there is one period of the tangent function. Now, again, it keeps going, right? If we put another asymptote out here, pi units away, we could, right? This would, pi units away would go to pi. I'm going to show you more than one period. The next 0 would be pi units away from the previous 0, right? This point would be 1.5. This point would be up at 1.5. And we could sketch a second piece of it like that. All right, you could also go the other way. You could get another piece going like this way, right? It's a periodic function. You'd see this curve repeat over and over and over again. All right. Again, I just need to see one period. That's okay for right now. Okay, asymptotes. The first ones I have, and again, we're going to label these as x equals. The first one I have is at negative pi over 2. Then pi units away is positive pi over 2. And then pi units away, if I want to label another one, is 3 pi over 2. And those keep going, okay? So be able to label a few of those. For the zeros, I only need one. The first one here is at 0, 0. So the first 0, 0, I can go before that if I want. If I subtract pi, be negative pi, would be before 0. Then pi units away from there is 0. The next one would be over at pi. I can keep going if I want to, then 2 pi, but then dot, dot, dot. Okay? So again, the asymptotes are always going to be one period away from each other, and the zeros are always going to be one period away from each other. These are periodic functions, so it just keeps repeating, 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 repeating. Okay. Let's try another one. So now let's mess around and change the period. Okay. So here we have 3 over 2. Now that's going to change my period. My period, I'll show the work down here, is pi, instead of 2 pi now, pi divided by 3 over 2. When I multiply by the reciprocal, I get times 2 over 3, which gives me a period of 2 pi over 3. Okay? So period here is 2 pi divided by 3. All right, now, so where it gets a little trickier. That's my period. That's going to be the distance from one asymptote to another, from one 0 to another. The question is, where are these asymptotes going to be? Right? I know I have one asymptote there, and I have one asymptote there. I know the midline is still y equals 0. So remember we said back here, if the period was pi, I went half a period to the right, and I went half a period to the left. Okay? That's what you have to do every time. So first, you got to take 2 pi over 3 and figure out what half of that period is. If you ever need to do that mathematically, with, you can't see it in your head, multiply it by a half. A half of the period then is just pi over 3. That's how far I need to take these asymptotes each direction, to the left and to the right. So to the right, this is positive pi over 3. To the left, this is negative pi over 3. Right? The reason I didn't go a full 2 pi over 3 is because pi over 3 and pi over 3 gives me a distance of 2 pi over 3. That's one period. That's how far the asymptotes need to be away from each other. All right? So you got to think a little bit there. Once you find the period, you got to think about where the asymptotes should be. Now, first 0 is going to be at 0, 0. The a value out front's 1, so these points are going to be there at 1 and negative 1. Now when I label these, this point here and this point here. Now the zero's pretty straightforward. Don't need to show any work for that. But just like with sine and cosine, I need to find 5 points. So I need to find that and that. It's the same way you've been doing before. Take the distance between 0 and pi over 3 and multiply it by a half. This is going to be pi divided by 6. The other way, this is going to be negative pi divided by 6. It's halfway to pi over 3. Okay, so I still need to see those 5 key values. Once you have it, you can sketch your tangent curve. Again, it comes close to your asymptotes, curves up, and then close to the asymptotes again. So we get that nice little curve. Again, this keeps repeating over and over that way. It goes to the left this way, right? We only need to see at least one period. You can always do more if you want. Okay, asymptotes then. Let's label the ones we have. We know x equals, there's millions before it, but with the first one we have labeled as negative pi over 3. We also then have positive pi over 3. We could keep going if we add another period. So pi over 3 plus a period of 2 pi over 3 gives me 3 pi over 3. So I know the next asymptote's at pi, and they keep going. All right. For the zeros, the first 0 I have here is at 0, 0. The next one's going to be 2 pi over 3 units away. All right. So again, positive or negative. So I know there's going to be a negative one at negative 2 pi over 3, a negative 0. Then there's one at 0. Then there's one at 2 pi over 3. If I add another 2 pi over 3, that's going to be 4 pi over 3, and et cetera, et cetera, et cetera. Again, you should be able to label more than the asymptotes and zeros that you have graphed because it's a periodic function, and those will always be pi units apart. I'm sorry, 2 pi over 3 units apart. In this case, they'll always be 1 period apart. All right, let's try a few more here. I think we'll do 2 more, maybe just 1 more. All right, so now here's what we're going to do. We are going to change both. All right, they're going to have an a value and a b value, just like we saw with sine and cosine. Okay, so here, period, if that's 1/2, my period is pi divided by 1/2, which gives me a period of 2 pi. All right, no amplitude, but the 1/2 is going to be a vertical shrink by a half. Midline is still y equals 0. So because we're not going to do this last example, just because it's very similar to this, maybe pause the video here, see if you can't come up with your asymptotes, and with a quick sketch of the graph and the zeros, and then we'll check your work. Okay, so if the period's 2 pi, I'm going to have asymptotes here and here. Now remember, this is the trick. I want the total distance between these to be 2 pi. So I can't go left and right 2 pi, right? This is the number one mistake. I see a lot of students put a negative 2 pi there and a positive 2 pi there because the period's 2 pi. This distance, though, is 4 pi. It's too far. So half of my period is pi, and that's how far I have to go right and left to get to my asymptotes, okay? Now, still need 5 values, so halfway between negative pi and pi is 0, okay? Halfway between 0 and pi over 2, between 0 and pi is pi divided by 2. And then if I go negative, halfway between 0 and negative pi is negative pi divided by 2. Again, you're just going to add those endpoints up and then times by a half. The exact same procedure you did with sines and cosines. Okay, now because of the 1/2 out front, I'm not going a full unit down here. I'm just going to go to 1/2. I got a 0 at 0, 0, and then another xy value at a half. So you can see this has been vertically shrunk by a factor of 1/2. So my graph's going to look like this, and you're going to be able to see the curve a little bit more here because it's been shrunk. There we go, something like that. And again, these are repeated, right? There's another one there, and there's another one there. You're just graphing at least one period. Okay. Again, just like with sine and cosine, I think the hardest part sometimes is the x-axis, the x values, remembering that you're going half a period each way to get to your asymptotes. Now, once you have the first few asymptotes, you can continue the pattern here, right? The first one we have is at negative pi. After that, we have it at pi. The next one's going to be 2 pi units away from that, so 3 pi. Then you could go to 5 pi, right? You could keep going with this pattern on and on. You just got to show me a few of them. So we'll stop there at 3 pi, and then it keeps going. Zeros, you got one here at 0, 0. Next one's going to be, well, we can even go before that. The one before that would be 2 pi units before it, so negative 2 pi, then 0, then positive 2 pi, then 2 pi, 4 pi, then 6 pi, right? Then 8 pi. because it's a periodic function. The zeros and the asymptotes are always pi units apart. I'm sorry, I said it again. Always 2 pi units, always 1 period apart. Okay, there's a good one here. It's good practice, but I don't want to do any more time. The video is already getting kind of long. But I do want to show you this real fast. This is a good skill where we kind of have to work backwards. What is the equation of a tangent function with a period of 5/2 pi? Okay, so the key to these is this formula here. The period equals pi divided by b. Okay, we did this a few times with sine and cosine. You got to remember with tangent, though, it's just pi. Okay, so if I know that the period is pi over b, and I know that 5 pi over 2 equals then pi over b, you can solve this little equation by what we used in the rational functions section, little cross multiplication, right? So if I do 5 pi times b, I get 5 pi b equals 2 times pi, right? Then if I divide both sides by 5 pi, I get 2 pi over 5 pi. But the pi is reduced to 1, so I get a b value of 2/5. So you can see what's kind of going on there. It's going to the value of my period here, the coefficient on front, is getting flipped when I make my b value. So the equation here would be y equals tangent. I'm going to run out of room. Hold on one second. Let me move this over. If it will let me move it over. Oh boy. There we go. All right. So my equation then is y equals tangent of 2/5 x. The b value is the value that goes in the equation. All right. So I always do it using this formula. B equals pi over b. There are patterns, but it gets tricky with remembering when to use what pattern, right? Especially when you start throwing sines and cosines in there. You can try this next one if you want. The value you're going to get is y equals tangent of 5 over 2x. So if you do the same equation and solve for b, you'll get 5/2. Okay? So that's just a good skill. Working backwards, if I give you the period, you should be able to give me the equation. All right, so that is the tangent graph. Next part of your homework is 34-4 worksheet. Again, check the answers on Schoology, and when done, submit it to Schoology. Now, I will say that I think these 2 worksheets are a little bit longer than a normal distance learning homework assignment. So if you don't get them both done today, that's okay. You know, I usually haven't been checking these or putting them into the grade book immediately. So I'll give you a little time here. I probably won't check this until Friday. These 2 worksheets, because they're, like I said, they're a little bit long. But make sure to check those answers on Schoology after you finish the problem, and then submit it to Schoology when you're done. If you're having any issues, as always, stop in and say hi and ask some questions on my office hour. Okay, have a good one, guys.